SolidCAM has many ways of dealing with parts such as the one we see here. What's special about this particular part, although it may look simple, but if I were to take a top view of it, you'll see almost every single wall over here is at a specific angle, and we even have these walls in the back over here which is at an undercut. And there's really no way to do this properly using only 2.5D options. So in SolidCAM we have a few options that we can deal with this. And in this particular part we'll be using the options of HSM, high-speed machining, to mill out most of them apart. And for those undercut part areas and specific surfaces, we'll be using the high-speed surface machining. We'll start off with our first operation, which will be a rough cut of our part. We'll go into the first operation that I've created. And you'll note, first of all, I'm using the contour roughing, which basically roughs out most of the material. The tool that I'll be using will be a 20mm tool, a relatively large tool to get as much material out as possible. The constraints will be automatic according to the stock material that we have. And the passes, I'll be going down every 3mm, and I'll be leaving a 0.5 millimeter of material for finishing. Remember, you can see all of these options. Every single field that I click, you can see what's going on the picture on the left hand side. Tolerances, step down. In my links, I'll be working on climb cutting. And let me just go back for my passes area. One other thing I did not note was the fact that I'll be working with detect core areas. In other words, if I can work from the outside into the part, in this particular case I can work in that sort of a fashion rather than working from a pocket out. My links, since I'll be working most of the time from the outside in, my ramping, I would do a plunging ramping. Now if I go into my simulation, you'll note, and I'll run the simulation a little slow, the tool is working from the outside, clearing away most of the material from all sides of the part, wherever there's material that can be taken off. Now you'll note also that in some cases the material that was left, since we went down every 3mm, is a little bit too big. These steps over here, a little bit too big for finish cuts. So we'll do another operation, what we call rest rough. On this second operation, I'll be using, like I said, the rest rough option. The tool, I'll be using a smaller tool, and obviously I'll be going according to the previous operation. In other words, work the rest rough only according to the previous operation marked off over here. My passes, I will still be leaving a 0.5 millimeters, but my step down will be a lot smaller. But you note when it does work, and I run this simulation over here, it'll only work in those areas where it has to take off the material. Notice, you know, on this wall area, in this whole open area, it did not work. Only in the areas where there's material to be taken off. And you'll also note that when it goes from one area to the next, it's using the shortest route. This can be pointed out if I bring your attention to the links as far as my retracts. We have the shortest route. If I were to do full vertical retract, now do save and calculate, you'll note that the tool will go up to the very single top every single time that has to go up instead of jumping over to the shortest possible route. Next operation, I'd like to start with a finish cut already. And what I like to do with this finish cut is just basically right now to work on this entire surface and this whole inside area. But we have two different options to work. First of all, we can work on these walls, these areas over here, using what we call constant Z. We're going down constantly until we get to the bottom. But the flat floors, as we see over here, we have something called horizontal. So instead of doing two separate operations of one horizontal and one constant Z, we have the option of using what we call a combined operation. Let me just go into my operation itself, and I'll be using a combined Z. I've used combined Z with horizontal machining. Now, my tool that I'll be using will be a 12 millimeter and with a 3 millimeter radius at the bottom of the tool. My constraint boundaries, however, this time, I'll be using it a little bit different. I won't create automatically, since I specifically want to work only on these surfaces over here. I've used the option of selected faces. If I go into my selected faces, first of all, you can see the boundary that's created. But if I go into my define area, and I show over here the faces I've selected, you'll see that I've basically selected these faces. These are the faces that I want the program to work on. Now, if I go into my constant Z, you'll see I have my step down as far as when I'm going down every single time. I have a separate for constant Z, my links. I'll be working bidirectional going back and forth. And then I also have the option of horizontal passes. And my horizontal passes basically is working on the floors of the part. My link, my ramping in, I'll be going in and a plunging. And one other thing that's important to notice that in my link over here, we have something called here machining order. In other words, if I want, I can have either the constant Z first, or I can first do the horizontal first. In this particular case, I was better off doing the constant Z first. And if I go into my simulation, you'll see that the simulation now is working on the walls. And then when it gets to the bottom, it'll work on the floors itself with wide steps, since we have a flat bottom on our tool itself also. If I were to use my solid verify simulation, you'll note, like I said, the tool is cleaning the outside as it's going down. And we'll let it run. And as we get down to the bottom, you'll see that it'll start working on the floor itself. You see each floor now is cleaned. And we've basically finished the inside of this part. Now, what you'll notice here also, however, is that we still have this surface here to do, and we also have this area over here to do. Now I can fool around and do some linear operations on these walls, but I'm going to use right now what we call high-speed surface machining to clean these areas. The calculation is very quick, and choosing it is also a breeze. If I were to go into my operation, I have my coordinate system, my geometry, and I've chosen the option of morph between two curves. In other words, what I'm doing over here is I'll be working on this surface, and I'm working morph between this curve and this curve. I have my selected face as shown here. I have my start edge curve as shown here. And of course I have my end edge curve as shown here. If I want, I can even extend the ends so that it goes past the part itself. Extend trim. As you see over here, I can exactly extend the past a little past the edge, so that way it doesn't stop exactly on the spot itself over there. The tool I'll be using a 6mm ball end mill. And my toolpath parameters, you'll note I can use here an option of scallop. If I change my scallop, let's say to 0.2, you notice that my maximum step over is automatically changed also. Change that, fine. If I change my maximum step over, you'll note that my scallop is also changed automatically. Go back here. Everything changes. These two options are connected one to another. Another thing will be working cutting method zigzag back and forth. And in my links area, I'll be using a lead in and I'll be using my lead out. And if there are any gaps, I will connect them. But let's take a look now at my simulation. And you'll note the tool is simply going down on the surface back and forth and leaving it. Very simple operation. Also, I just go back and do the calculation, even though I've calculated it already before, just to show you how quickly the calculation actually is. That was it. Now, I've done the same thing in my next operation for this surface here also. Let's do that a simulation of both of these operations. And I'll use my solid verify simulation. You'll see that it basically works on this wall over here and then cleans this surface over here. Done very quickly and very simply. Now I'd like to deal with these surfaces in the back over here, including this wall over here, this undercut over here. Remember, all these walls over here are actually an undercut. In other words, they're in a negative direction if I look from the top down, as you can see. So in other words, the only way I can really do it now is we have the option also again of high-speed surface machining, because high-speed surface machining allows us to work on undercut areas and also gives us a tool called gouge control, which if I see the arbor or any part of the tool hitting an area where I don't want it to touch, it won't ruin those areas either. It'll act whether I can pull it away from that area or just stop the calculation and finish my operation at that point. Let's take a look at what I've done. I'll open up this operation, and I've simply chose my geometry with using parallel cuts in the Z direction. And if we look at the faces that I've selected to do, you'll see I basically selected, I've even selected these sides over here also to have one smooth cut all around. Now the tool that I will be using in this particular case will be a slot mill, a T-cutter, or Woodruff cutter, whichever name you prefer. And I'll be using with a diameter of 36 millimeters with a 1 millimeter radius. And we'll also note that the arbor itself is a 10 millimeter arbor. Now, my toolpath parameters, I'll be going down every 0.1 millimeters, and I'll be working zigzag. Now, of course, I have my links. I'll be going in and out using a radius. But we have here something else which I've mentioned before. We call gouge check. Now, in my gouge check, I've enabled my gouge check, and I've said, okay, if I see that my holder or my arbor hits any of the drive surfaces, in this particular case, these are the drive surfaces what I'm worried about, I can tell it move tool away, or even stop tool calculation. If I do save and calculate, which is also relatively quick, and then do my simulation when this finishes, first of all, let's take a quick look at our toolpath. And you'll see that the toolpath goes down on the side over here, coming in from the outside over here. Remember, I've gone down every 1/10 of a millimeter to give it a nice full surface. Now note what happens when it gets to the bottom. It'll curve its way underneath and then retract to the outside. If I were to use Solid Verify instead, you'll see that the tool is working its way around the back. And if I were to use the top view and get rid of my holder, you can see exactly what's going on. Let me just stop it here for a moment and just do one step at a time. You'll see now that the tool, when it gets to this area here, I'll try and stop it again. You can see already over here that the tool is actually underneath the top of the surface. It's already past that area. Let me just continue now with the rest of my simulation. Now bring the tool holder back. And you'll see that's all being cut exactly the way it should be. As it gets down to the very bottom, you'll see it'll start curving its way in. And basically now we've cleared off all that material that still has to be cleared off. Now, the last thing I like to do just to finish off this part is, you see this text over here? I like to actually engrave this text onto the part itself. So the way I've done it is, again, I've used this time the HSM option, and the option that I've used over there was boundary machining. Basically what that does is I pick a boundary that I wanted to work on, such as the text that I've seen here, and I'll show that to you in a moment, and I wanted to go with a tool that has a point at the bottom, and I want to basically go on the drive boundaries, which is my text, and I want to continue. I want to work obviously in the middle. My constraint boundaries is obviously my part itself, and all I've done is in my passes I've told it axial thickness of minus 0.2. I left my regular thickness as 0, but axial thickness of minus 0.2. By doing this, I've actually forced the tool to go further into the part itself. Let's just take a quick look at my simulation, and you'll note that my toolpath goes on the text itself. And if I were to use my Solid Verify option of simulation, you'll note, you can see in my simulation that the text is being machined out exactly the way it's supposed to be done, all the way to the bottom. Basically now we've completely finished machining out this entire part using HSM and the HSS options.